we start a new part D, power and energy in integrated circuit. So this topic is short, pretty short. So before I talk about this topic, I want to give you three more examples. Continuation from part C. Part C, I gave you, 2 examples, right? Yeah. So here, let me give you another 3 examples. Because later we will have many computation questions. Some of them not very easy to solve. So if you have the background of these examples, that could help a lot. Yeah. All right, so let's start our first example. Yeah. Example number 3. All right, suppose that we use the formula, so this formula, to estimate the number of dies of size 1 by 1 square inch that can be produced in a wafer with radius r. Here, why this formula? Can you see that? Can you see why this formula? Right? Yeah, let me explain. From our original formula, we can get this expression easily. From our DPW formula, dies per wafer formula, we derived in part C. Yeah, remember these 2 terms. Because diameter D equals 2r, radius 2r. So you plug in, so here you get r squared, right? And remember, dies of size 1 by 1, for simplicity, 1 by 1 square inch. Yeah, so it's a square, 1, like that. Okay? So for our computation, it is very easy. 1 by 1, 1 times 1, right? Yeah. So area, it is 1. So the denominator for the first term is gone. Okay? Then here, replace D by 2R, right? So die area 1, but 2 over root 2, so you get square root 2 times R. So you have that, you have this expression. So after we simplify the original formula with the given information, we get a simplified formula. Okay? Yeah, so that's the reason. Yeah. So now we just use this formula directly. Okay, yeah, all right. So look at the question. If we take R equals A the first time, R equals A, diameter A, we get the number N from the number of N dies on this wafer from the formula, from that formula. If we take R equals 2A, double the radius, we get the number N from the formula. Okay, N and N. All right, yeah. Now, the question, which of the following is correct about the relation between N and M in general? Okay, so 3 relations. A, M equals 4 times N. B, M less than 4N. C, M greater than 4N. You need to do some calculation and tell me which one is correct. So that's our example 3. Yeah. All right. To solve this problem, it is not very hard, but you need to use some right method to do it. Yeah. So here, I want to talk about comparison. Here we do comparison, right? Compare M and N. We do comparison. So we compare these 2 expressions. The first expression, N equals, we plug in R equals A. So that's N. Second, M expression, plug in 2A for R. Yeah. So two expressions. So now we compare these two expressions. Okay. So when we compare, look at what is the right way to compare? Right way to compare. We need to use some special method to do it. Yeah. All right. So here I want to talk about what is the usual ways to do comparisons. Yeah. Here I want to talk about two commonly used methods in comparison. The first one called difference-based comparison. Difference-based. You need to do difference-based comparison. Second, called ratio-based comparison. You take a ratio, then you calculate the ratio to tell you the comparison result. All right, yeah. So here, for example, for this question, when we do ratio-based comparison, we want to calculate this ratio, m over n. What is this ratio? This ratio will give us the answer. All right. If we look at the first method, difference-based method, we want to calculate the difference of two numbers to give us the answer. But what difference we want to look at? Okay. Look at the options we have. A, B, C option. You should get some hint from A, B, C option. A, B, C option, we compare m with 4n. So if you take the difference, you need to take n minus 4n. Can you calculate that difference? Right? Yeah. So these two methods. Okay. All right. So next, let's do the work. Do the calculation, the work. Let's try the ratio-based comparison first. M and n expressions given here. So let's just do the ratio. M over n, so we write in this way. All right. But when you put the expressions like this, first we need to do some observation to explore its properties. The observation you can see, look at the first term, you get a 4-to-1 ratio, right? 4-to-1 ratio. Then if you look at the second term, you get 2-to-1 ratio. 2-to-1. 1 4-to-1, 1 2-to-1. Different. So if different, then how do you make them connected? So the difference, but make them connected in some special way. Yeah. Now I do this because I want to make that 4-to-1 part correct. Right? So look at this. I make this 4-to-1 part. Yeah? To match the first ratio part. To match that. Okay? 4-to-1, 4-to-1, right? Yeah. So in this way, you can see the whole thing 4-to-1. But you need to make a correction here. Plus 2√2 pi a to make it the same as before. To make the numerator the same as before. You cannot change the numerator, right? Here we just change the form, but we cannot change its value. Okay? We keep the same value. Yeah. But we need the first part. Because if we have the first part, 4-to-1, then we can simplify 4 plus of some fraction. Some fraction. Okay? Yeah. But we know this fraction is positive, right? The numerator positive, denominator, when a is large enough, look at that. So when a is greater than √2, no problem. Yeah. For a wafer, we know the a should be much larger than the die size, right? Die size is 1. A should be much larger than the die size. So a greater than √2, that's no problem. Yeah. So denominator also greater than 0. So then the whole fraction greater than 0, right? So 4 plus a positive number greater than 4. So the ratio greater than 4. What conclusion can you get? M over N greater than 4. Then you get M greater than 4N, right? So you can get M greater than 4N. So that's the ratio-based comparison. Yeah. How about that? Yeah. Next, so let's look at the, difference-based comparison. This time, we just take the difference. 4 minus, n minus 4n. n minus 4n. Yeah. Plug in two expressions. First term cancel out, right? So then the second term, plus minus, change sign, move terms a little bit, you will get 4 root 2 pi a minus 2 root 2 pi a. Simplified, 2 root 2 pi a. It is positive. The difference is positive. Can you get the same thing? Option C. So you can see these two basic methods both can give us the correct answer. You just choose one that you like. Okay? Yeah. So, all right. Yeah. Here, from the calculation point of view, it looks like the difference-based method a little easier in this question, a little easier than the ratio-based questions, the method. But the ratio-based method has small advantage in one way. If you do not know that 4, right? If you do not know the multiple 4, you can still use the ratio-based method to calculate that multiple. But for the difference-based method, you have to know that multiple 4. Then you can do the calculation. Otherwise, you will calculate the wrong difference. Okay, so that's the main difference between these two methods. All right, so let me finish the first video, D.1.